The last major type of quadratic story problem is projectile motion. So first, let me draw you like a little bit of a picture of this and what that's going to look like. So when you have something like this, when something is thrown, you have different parts to that. These are zeros, or they could be called roots. Okay, so then this is where we initially start at, a height. This would be the vertex, its highest point, and then it would come back down to its other zero. So as you're throwing something up, it's going to have like an initial height, it's going to have a highest point, so on and so forth. Okay, your equation can vary in this from thing to thing, and usually that's going to be given to you. So I'm kind of going to skip over that part at the moment. So zeros. What do zeros mean? Well, unless you're my child, nobody throws backwards, so you're not going to have any negatives. No negatives. Then the questions that you're going to ask yourself for this are, when will it hit the ground? And your other question should be, how long was it in the air? So those are going to be the two types of questions that are going to ask you, like, where are you finding the zeros? So your y-intercept is going to be, how high did it start? And my vertex, the x part, is going to be when, that's the key word, when, for time, is it at its max height? And my other key question is going to be the y value of this, how high does it get? So how high? Okay, so those are your keywords that you're looking for. So now let's go through and read these and say, what is it asking me for? So how long is something in the air? So how long is something in the air means how long does it take to get from here to here, the up to the down. So you're calculating to get to a bottom point, so that's a zero. How are you going to find zeros? Well, there's a few ways. You can factor. You can use quadratic formula. You could use a square root property. Or you could use completing the square, but you probably won't. Your next question, how long does it take to reach the ground? Well, same thing. How long is time for it to go up and come back down? You're finding a zero. All of these same things apply to that. What is the maximum height? So think about it. Maximum height is right here. The maximum height of that is going to be the y value of the vertex. How long until it hits its maximum height? So maximum height is still the vertex, but the how long part is your time, so that's the x value of the vertex. How high after so many seconds would be to plug time into the equation. All right, so then let's look at some examples of this. So the height of a ball thrown by a child is modeled by the equation negative 12x squared plus 2x plus 3, where x is the horizontal distance in feet of the ball thrown. So how high is the ball when it leaves its hand? Okay, so what it's asking for here is a starting point. So what we know is the starting point is the y-intercept, and we know that the y-intercept is our c value. So this is an easy question. What's our c value? It's 3, so it starts 3 feet in the air. So the kid's probably about 3 feet tall. What is the maximum height of the ball? Maximum height of the ball is the vertex. So you're saying, what part of this do I want? Well, the thing that is height is the y value. So to get the y value, you have to go through and find the x value first. So don't forget our equation for this is negative b over 2a. We did that a whole bunch in chapter 2. So negative 2 divided by 2 times negative 12. Negative 2 over negative 24, which is 1/12. Okay, so that's our x value. So we need to take that and plug it back in. So negative 12 times 1/12, 2 times 1/12, plus 3, And that is going to give us 3.08. And that's going to be in feet. So the kid doesn't really throw the ball very high. It's at its highest point at 3.08 feet. So he's barely getting it much higher than he is, which is logical for a child. How long is the ball in the air? Okay, if you want to know how long a ball is in the air, you want to find your zero for that. So you want to decide if you're going to factor that or if you're going to do quadratic formula. I generally pick to do quadratic formula because it's going to work 100% of the time always. So opposite of b, -2 plus or minus the square root of b squared, so 2 squared, minus 4 times a times c, all over 2a, so 2 times -12. Okay, so then that's going to give me that -2 plus or minus the square root of 148 over -24. So that's going to give you two different things. That's going to give you -0.59 and positive 0.42. And that is time. Okay, so how long is it in the air? For time, is that we want the positive of this. You can't have negative time, so 0.42 seconds. So the next question is asking us how far from the child does the ball land? So we're going to take that 0.42 seconds, and we're going to plug that into the equation. So plug in our 0.42 seconds. Because we know the time, so we need to find the f of x, which is our distance. So -12 times 4.2 squared plus 2 times 4.2 plus 3. So when you evaluate that, you get 1.236. Okay, so that's about 1.2 feet away from the child. So he threw it 1.2 feet. Pretty logical if this is a small child. Okay, so let's look at a couple other examples of this. Okay, your club is selling boxes of cookie mix as a fundraiser. The total profit P depends on the amount that your club charges. The equation is given to you. What's the smallest amount in dollars that you can charge to make a profit? Okay, so in this, X is equal to money and P is equal to profit. So you need to make at least $150. $150, so everything has to be greater than that. So that has to be greater than our equation. So again, this is the smallest amount you can make is the 150. So the equation has to be bigger than that. That's why your sign is pointed in that direction. So if you want to solve this, you want to find your zeros. So you would use the quadratic formula. So if you're using the quadratic formula, this -150 has to come over to the other side. So I would set this up with an equal sign now. -0.5x squared, 30x, and then this is going to give me -270. So now I can put this in the quadratic formula. The opposite of b is -30 plus or minus the square root of 30 squared minus 4 times a times c all over 2a. So when I solve that, I'm going to get -30 plus or minus the square root of 360 all over -1. So when you solve that, the square root of 360 is not perfect. So what you're doing is you're getting -30, and it's going to give you 18.97. So plus 18.97 over -1. And then -30 minus 18.97 over -1. So -30 plus 18.97 is going to give me -11.03 over -1. So that's 11.03. Okay, when I do the other one, I'm going to get -30 minus -18.97. Oops. And that's going to give me -48.97 over -1. Okay, so what's the smallest amount? So this is going to give me 48.97. What's the smallest amount?